안녕, welcome to K-Math. Today, we are going to focus on how to find the slope of the tangent line using limits. Have you heard of the word derivative before? It's just another word for the slope of the tangent line. And that slope is what we call the instantaneous rate of change. In some countries like the UK, people also say gradient. They all mean the same thing. We are really talking about the same idea, just with different names. Let's say we have a graph of f of x and 2 points on it, P and Q. Point P is a comma f of a. Point Q is b comma f of b. The line connecting P and Q is called the secant line. Remember, the slope of the secant line is f of b minus f of a over b minus a. Let's get a little bit more specific. Let's say b is h units away from a along the x-axis. Then we can write b equals to a plus h. And f of b becomes f of a plus h. So its coordinate is a plus h comma f of a plus h. Then the slope becomes f of a plus h minus f of a over a plus h minus a. A minus a is 0, so the bottom becomes just h. That gives us f of a plus h minus f of a over h. But this is still just the slope of the secant line. Here, the red line is the tangent line at point P. The purple line is the secant line between P and Q. Now, what happens as the value of h gets smaller and smaller? Let's take a look what happens visually. You will see point Q getting closer and closer to point P. So, you can see point Q is getting really close to point P. In other words, as h gets really small, the purple secant line gets closer to the red tangent line. And at the limit, it actually becomes the tangent line. Let's try to find the derivative. We start with this expression f of a plus h minus f of a over h. Again, this is just the slope of the secant. For the slope of the secant line to become the slope of the tangent line, the value of h here must get closer and closer to 0. That's the key idea. Without that, it's just the slope of the secant line. In math, we write it like this. We say this part as limit as h approaches 0. Just to be clear, h approaches 0 doesn't mean h equal to 0. It means h is really close to 0, like 0.001 or 0.000001. It's never actually 0. And this expression is defined as the derivative. We write it like this, and we read it f prime a. From now on, we will use this notation for the slope of the tangent. We call this method the first principle. It is also known as the instantaneous rate of change or the gradient. They all mean the same thing. Let's try an example. Let's start with something simple, and we will try more challenging ones like square root or rational functions in the next video. So, here's the question. Determine the slope of the tangent to the graph of the parabola f of x equals x squared minus 4x at x equals 3. We are going to use the first principle to find the slope of the tangent at x equals 3. Let's recall the first principle. Limit as h approaches 0, f of a plus h minus f of a over h. It means the slope of the tangent, which is f prime a. This is a parabola that opens upward. We can factor the function as x minus 4. So the x-intercepts are 0 and 4. The vertex is right in the middle at x equals 2. So the graph looks something like this. We want to find the slope of the tangent line at x equals 3. At x equals 3, the y value is f of 3, which is 3 squared minus 4 times 3 equals 9 minus 12. It gives me minus 3. So, point on the curve is 3, minus 3. And that's where we want to find the slope of the tangent line. In this question, a equals 3. So, the slope of the tangent line is limit as h approaches 0, f of 3 plus h minus f of 3 divided by h. To get f of 3 plus h, just plug x equals 3 plus h into the function. Then f of 3 plus h becomes 3 plus h squared minus 4 times 3 plus h. 3 plus h squared is 9 plus 6h plus h squared. Minus 4 times 3 plus h equals minus 12 minus 4h. Let's combine like terms. H squared, 6h and minus 4h, and 9 minus 12. It gives us h squared plus 2h minus 3. Then plug everything into the formula. The slope of the tangent is limit as h approaches 0. f of 3 plus h is h squared plus 2h minus 3. h squared plus 2h minus 3. And f of 3 is minus 3. Minus 3. Over h. Minus 3 cancels out. And the numerator becomes h squared plus 2h. And the denominator is h. Now, let's think about what happens as h approaches 0. If you plug in a really small number for h, both the numerator and denominator approach 0. That gives us 0 over 0. This is an indeterminate form. And when we get an indeterminate form like this, we need to simplify the expression further. In this case, we can do that by factoring the numerator. Then the expression becomes limit as h approaches 0, h plus 2 over h. We have h on the top and h on the bottom, so cancel out each other. Now we have limit as h approaches 0, h plus 2. As h gets really close to 0, h plus 2 just becomes 2. The slope of the tangent line at x equals 3 is 2. So that's how we can find the slope of the tangent line using the first principle. That's it for today. Thank you for watching. See you next time. Bye.